I'm going to start reading Kidney Embryology from First Aid 2025 and then explain things in a picture and mnemonic, and then in the comments below I'm going to attach USMLE-Style questions. Now let's get started. Kidney embryology. Pronephros, it happens in the week 4 of development and then it degenerates. Okay, and where is the pronephros? It is right over here. Okay, this is the pronephros. And then the mesonephros, it happens also in the week 4 of development, and it functions as an interim kidney for the first trimester in both sexes. And mesonephric ducts persist in the male genital system as the Wolffian duct, forming the ductus deferens and epididymis. Mesonephric ducts degenerates in females. So where's the mesonephric ducts? It's right over here. It's in the middle. Okay, this is the mesonephric duct right over here. Last thing is the metanephros. Metanephros is permanent. Metanephros, which is right here, this part. Metanephros is permanent, and it first appears in week 5 of development, which is 1 week after week 4, right? So metanephros is permanent, and it first appears in week 5 of development. Nephrogenesis is normally completed by week 36 of gestation. Now, metanephros, they further divide it into three points. Metanephros are further divided into 3 points. You have the ureteric bud, then you have the metanephric mesenchyme, and then another note. So ureteric bud, or the metanephric diverticulum is this part right here. So if you zoom in, the metanephric diverticulum, or the ureteric bud, is right over here. Okay, so this ureteric bud or metanephric diverticulum is fully canalized by week 10 of development, and it is derived from the mesonephric duct. It is derived from the mesonephric duct right here. It is derived from the mesonephric duct to form the ureters, pelvis, calyces, and collecting ducts. Then we go on to read metanephric mesenchyme. Metanephric mesenchyme, or the metanephric blastema. Where is this part? Here it is. This is the metanephric mesenchyme, or the blastema. Here they say that the ureteric bud, which we just discussed here, ureteric bud interacts with this tissue, the metanephric mesenchyme. Ureteric bud interacts with this tissue to induce the differentiation and formation of glomerulus through the distal convoluted tubule. Last point, they discuss aberrant interaction between these two tissues, which is the metanephric mesenchyme or the blastema and the ureteric bud. Aberrant interaction between these two tissues may result in several congenital malformations of the kidney, like renal agenesis and multicystic dysplastic kidney. Then they say that the uretero-pelvic junction is the last part of the ureter to canalize. If it doesn't fully canalize, then this will lead to congenital obstruction, and it can be unilateral or bilateral, and most common pathologic cause of prenatal hydronephrosis. Okay, most common pathologic cause of prenatal hydronephrosis, and it is detected by prenatal ultrasound. So let's go ahead and explain all that we read. So how are the kidneys formed? We're going to divide the kidneys into pronephros, mesonephros, and then metanephros. So how are we going to remember the order of pronephros, mesonephros, metanephros? So the way to remember the order of pronephros, mesonephros, and metanephros by using a mnemonic, which is P, M, and then another M, PMM. Okay, where P goes for the pronephros, these pros that start the whole process of making a kidney. The other M, or the first M, goes for mesonephros with an S, and then the last M is for metanephros with a T. So why am I focusing on these letters, S and a T? Because for you to remember that in the alphabets, the letter S comes before the letter T, and this is why it's always the mesonephros and then the metanephros in terms of order. And another way to remember kind of the function of each of these, so the pro is the one that's going to eventually degenerate. It's the professional that started everything, but it's a sad story. It went away, and we no longer have to deal with that. The mesonephros is S. You could think about S goes for sample. Why? Because if you think about it, the mesonephros is going to be an enterum kidney. So it's like it's being a sample up until you have your permanent kidney. And meta, T goes for, it's like kind of like the end letter of permanent. So if you think about, if you spell out permanent, I did a poor job of that, but if you spell out permanent, permanent for meta. But if you remember S for sample kidney, then you just, conclude that the meta is your permanent kidney. It's the final product, right? So let's go back here and see what I just discussed. So we started with the pronephros right here, and what did we say about the pronephros? Pronephros are going to start at the week 4 of development. Okay, they will start at week 4 of development, and then they will degenerate. Now, mesonephros also will start at week 4 of development. And what did we say about meso? S is for sample. What do you mean by S for sample? It's a sample kidney. Also, what do you mean by sample kidney? That means that it's going to function as an enterum kidney for the first trimester. It's going to function as the enterum kidney for the first trimester in both genders. And this is very important to understand that the mesonephric duct, okay, the mesonephric duct, which is inside of the mesonephros right here, is going to persist in the male as what is known as the Wolffian duct. And the Wolffian duct is what's going to form technically the inner parts of the male system, like the ductus deferens and the epididymis, while the mesonephric duct degenerates in female. Let's look at that in a picture that kind of explains things more. This page explains genital embryology in like a more comprehensive way. And remember that in genital embryology, I know this is annoying, but it is what it is. We have to understand that both male and female, they start with this. They start having an indifferentiated gonad right here, okay, an indifferentiated gonad, and then lying next to the indifferentiated gonad is the mesonephros, the circle right here, the mesonephros. And what's inside of the mesonephros is going to be the mesonephric duct, okay, this tube, it's the mesonephric duct. What's going to be next to the mesonephros? Next means para, so it's going to be the paramesonephric duct. Okay, that's going to be the paramesonephric duct. And then this is going, both of these, mesonephros, paramesonephros, will lead to the urogenital sinus. Why am I talking about this? Because this is going to decide if the gender, if it's going to be male or female. So this is going to be decided upon the fact if you have androgens or not. If you have androgens, then this is where the gonad is going to differentiate into a testes. If you do not have androgens, then the gonad is going to differentiate into ovary. Now, let's say we did have androgen and then the gonads differentiated into testes, then what's going to happen to the mesonephros or the mesonephric duct? This is why I'm trying to discuss this, because we were talking about the mesonephros. What did we say about the mesonephros? They're these guys that happened at week 4 of development, and it functioned as the sample / enterum kidney. Meso, S for sample, enterum kidney. Okay, enterum kidney for the first trimester, and then the mesonephric duct, this one right here, in a female, if you look right here, it's going to degenerate. Okay, it's going to degenerate. But in a male, it's going to persist. The mesonephric duct is still there. And what is it going to transform into? It's going to transform into the male internal structures. So things like the epididymis, things like the vas deferens, any internal male structure. And here you could read it develops into male internal structures like seminal vesicles, epididymis, ejaculatory duct, and ductus deferens. Now, let's go back. Mesonephric duct in females is going to degenerate, but in males, it's going to transform into the Wolffian ducts, which is going to give things like ductus deferens and the epididymis. Now, the third structure that we need to talk about is the metanephros. Metanephros is made of 2 structures, okay? It's made of 2 structures. Let's zoom into it. The metanephros are made from the urethric bud, okay? Urethric bud, this duct right here, which if you concentrate, it comes from the mesonephric duct, so it's a continuation of it. So metanephros is made of a ureteric bud, the stalk, and this circular structure, which is the metanephric mesenchyme, aka the metanephric blastema. Now this is where embryology is going to get very, very annoying. And there's going to be two names for each of the structures that I'm talking about. So for ureteric bud, okay, it goes by another name, which is the metanephric diverticulum. Before I go ahead and read what's written in the first aid, let's just think about it for a second and think, why did they name it ureteric bud, and why did they also name it metanephric diverticulum? Well, what does ureteric mean? It comes from the word ureter. So that indicates that, oh, ureteric bud is going to eventually give me my ureters. The other name for ureteric bud is metanephric diverticulum. Why do they call it that? Why? Metanephric comes from the word metanephros, right, which is the adult kidney. So the metanephric indicates that it comes from an adult kidney. And a diverticulum means that you had an outpouch or branching of the mesonephric duct. That's why they called it a diverticulum. So now we understand why it's called ureteric bud or metanephric diverticulum. Now, the ureteric bud, okay, is fully canalized by week 10 of development, okay? It's fully canalized by week 10 of development, and it is derived, like we said, from the mesonephric duct. And what does this form, the ureteric bud? It's going to form from its name, ureteric. It's going to form the ureter and then the rest of the collecting system, so things like the pelvis, calyces, and collecting ducts, okay? Now, what about the metanephric mesenchyme? The metanephric mesenchyme, aka the blastema, metanephric blastema, the way I remember is that the metanephric blastema is going to have a blast informing the rest of the kidney. And this is where the ureteric bud is going to interact with the metanephric mesenchyme, and then it's going to form the rest of the kidney, which is from the glomerulus through the distal convoluted tubule. Because we mentioned that the ureteric bud forms the ureter and the collecting system, right? From its name, ureter collecting system. The metanephric mesenchyme or the blastema is gonna have a blast informing the rest of your kidneys, which is the glomerulus, through the distal convoluted tubules. Now, what if we're having an abnormal interaction between the ureteric bud and the metanephric mesenchyme? Well, here they tell you, aberrant interaction between these two tissues may result in several congenital malformations of the kidney. And this is high yield because that's a clinical tie-in, like renal agenesis and multicystic dysplastic kidney. So this is where the USMLE can sometimes ask you questions like, oh, someone's having a history of multicystic dysplastic kidney disease, and then they're asking you, like, embryologically what happened, and you need to understand that this is an abnormal interaction between the ureteric bud and the metanephric mesenchyme. And sometimes they confuse, you need to know the two names of metanephric mesenchyme or the blastema. You need to know that the ureteric bud is also called metanephric diverticulum, and that's easy to conclude because the bud is really an outpouch, and a diverticulum kind of means an outpouch, so that's easy to remember. Last part that we have here is that you need to remember that the ureteropelvic junction is the last part of the ureter to canalize, and if it does not fully canalize, then this is going to lead to obstruction. And could be unilateral or bilateral, most common pathologic cause of prenatal hydronephrosis detected by prenatal ultrasound. So let's reiterate what I just explained in a picture that I found here online, and this really kind of emphasizes or summarizes everything that we just discussed. So if we look at the kidney right here and kind of zoom in, you could tell that it's PMM. P for pronephros, okay? And then M is for mesonephros, sample kidney. And then M is for metanephros, right here. This is your metanephros. So the pronephros, these are the pros that started making the whole kidney, right? So they will degenerate, as we said, in week 4 of development. The mesonephros also is going to start happening in week 4 of development, just like the pronephros and the mesonephros. S for sample, they're going to act as a sample kidney or interim kidney in the first trimester for both kidneys. Mesonephros degenerates in females, but it persists for males as a Wolffian duct. Okay, and what does the Wolffian duct form? It's going to form the male genital system, forming ductus deferens and epididymis, or the internal male genital system. And then for the metanephros are a little more complicated. The further you go, the more complicated embryology gets. The metanephros is going to form 2 structures: the bud, the ureteric bud, aka the metanephric diverticulum, because that's a pouch, and the blastema, the metanephric blastema, or another name is metanephric mesenchyme. If you zoom in, this shows the structure in depth. So if you look, here we have the mesonephric duct, right? And the mesonephric duct persisted to give the ureteric bud, And then the ureteric bud, or the metanephric diverticulum, same name, is going to interact, this is the word, is going to interact with the blastema, the metanephric blastema, which is going to have a blast making the rest of the kidney. And then this is where the interaction happens, and then this used to be the ureteric bud. Ureteric bud's going to form the ureter. It's going to find the ureter and the rest of the collecting system. What is the collecting system? The renal pelvis, and then you have the calyces, major and minor calyces, and then the blastema is going to form the rest of the kidney, which is going to be from the mesonephric, which is going to be the rest of the kidney, which is going to be from the glomerulus throughout the distal convoluted tubule.